Welcome to the series on microprocessors. So, if you look at the syllabus contents, you'll see that you'll be going through you'll be understanding the basic terminologies that are associated with microprocessors. You are familiar with some of these terms. Nowadays it has become nowadays we talk about the processor type, the memory, the storage, the RAM, the ROM. All these things are actually talked about with regards PCs, with regards our mobile phones. Fine. We know about the various types of processors, be it Intel i5, i7, or even if we talk about mobile processors like Snapdragon. So these are some things which we are nowadays familiar with. We understand we understand the capability of a 2 GB RAM and an 8 GB RAM. We can understand it's a faster system, but we need to look into depth what exactly a RAM is, how it actually processes data, and we'll be taking a look at a special type of microprocessor that has been used in a lot of applications, and that is 8085 8-bit microprocessor that we'll be looking into. We'll be understanding its architecture, its addressing modes, its pin diagram, the various instruction sets that are associated with 8085 microprocessor, as well as the interfacing with other devices. And uh, apart from this, we'll be also looking at how we can access the memory of such systems, some other terms that are associated with microprocessors like interrupts, uh, counters, extra. These will be looked into. We'll try to understand what these mean and how, with regards in relation to 8085, how they actually work. Fine. So starting off with the basic term that is the microprocessor, we actually have three things that we need to take look into first. Three definitions. One is the microprocessor itself. Second definition will that be of a microcomputer, and third uh, definition that we'll be looking into is that of a microcontroller. So a microprocessor, it is a multi-purpose programmable logic device that will actually receive binary data from an input device and process it as per the instructions that are actually already written in the memory set and provide us a process data as output. Fine. So it's a program multi-purpose programmable logic device that will receive binary data from an input source from an input device. It will process it as per the instructions written in the memory, and provide a resultant output, provides the process data as output. It's a standalone device. It's a separate device, not a standalone device. It is something that will be separate from a memory. It will be separate from an input device. It will be separate from the output device. It will be actually only the processing unit that will be referred to as the microprocessor. A microprocessor will be separate from an input, it will be separate from an output, and it will be separate from a memory. So if we look at a general block diagram, we'll have an input device, we will have the central processing unit, that will be actually the microprocessor. We'll have an output device. This is input device. This is an output device. We have the central processing unit. There will be the memory. That can be it's dual X. That this double arrow here means basically you can read from the memory, you can write on the memory. Fine. So this is your basic block diagram. Fine. There is a central processing unit. This central processing unit is the programmable device that will actually receive binary data, that will actually process that data by the from this using the instructions that are already written onto the memory, and process that data and send it to the output device. This central processing unit can be interfaced with any input device, can be interfaced with any output device. Not exactly with any, but there can be a number of input devices, a number of output devices with which it can be interfaced. And so and also the memory will be accessible to, so that we can change the instructions, we can modify the programs again and again. And so this is therefore a multi-purpose device. Fine. So you can use it for various applications, various process applications. On the other hand, a microcontroller, as against a microprocessor, a microcontroller is a complete computer, or you can say a system on a single chip. That means the input device, the input ports, the output ports, as well as the memory, they are actually associated with the processing unit. They will represent a complete system on a single chip. Fine. They will not. You cannot separate the input from the processor here. You cannot separate the output from the processor here. You cannot separate the memory from the processor here. A microcontroller will have all these things embedded, and therefore they can be used for only some particular application. It will not be a multi-purpose device. As we talk in embedded systems, like say for example a washing machine, you can have a microcontroller. Fine. That will actually be used for that particular application. Say for example, it may be used for spinning the drum of a washing machine accordingly, and you can also incorporate various other programs. Say for example, today we use fuzzy programming in washing machines. Fine. So it will have an inbuilt program. You cannot modify that program. You cannot change the input type. You cannot change the output type here. So it will be used for only one particular application in a washing machine, say for example. You cannot modify this system. You cannot access this system. Once written, it may be permanent, and you cannot change the programming or the purpose for which it has been built. Fine. So it's a single purpose device. It is not a multi-purpose device. A microprocessor stands alone, so you can interface it with the number of input devices, with the number of output devices. You can change the instructions on the memory, and accordingly you can change the program on the memory. So you can use it for multi-purpose applications. But a microcontroller, it has all these things embedded on a single chip, so you cannot you cannot change, you cannot edit the program here. It will be used for one single purpose only. Fine. As far as microprocessor and microcontroller go, they are actually uh, they are opposed to each other. A microcomputer, on the other hand, is simply a computer whose CPU is a microprocessor. So this block diagram actually we have drawn. This whole block diagram is actually a microcomputer. This CPU in it is a microprocessor. Fine. Uh, Now, if this CPU is a microprocessor, and that means you can actually change its program, you can change the input type, you can change the output type, then it becomes a microcomputer. But if you cannot change this CPU, you cannot change this input output and the memory itself all on a single chip, then it is actually a microcontroller that's actually built for one single purpose only. Fine. Now, as far as microprocessors go, you have an 8085 microprocessor, fine. And if we talk about microcontrollers, there is 8051 that can be. So, इसकी जो example है, this is example of a microprocessor is 8085. These are actually and example of a microcontroller is 8051. Fine. This 8085 is actually an Intel make. Moving on. Uh, Now coming to the language that the microprocessors understand, you may have heard about machine language, assembly language, high-level language. Uh, so the machine language, first of all, it is actually the directly understandable language that these are simply the binary digits, strings of zeros and ones, fine, that the processor directly understands. The microprocessor directly understands this type of language. So since it directly understands this type of language, machine language is actually it's a one-to-one communication, and therefore it is much faster. Fine, it is faster because of owing as it is a one-to-one communication. We do not need to translate this language for the microprocessor to understand. Also, it requires less memory space, or you can say it's more compact. However, there are disadvantages associated with machine language. These are some of its advantages. The processor directly understands this language. It is faster. It's a one-to-one communication between the microprocessor and the device, as well as if the device is talking to the microprocessor in machine language, as well as it is compact, requiring lesser memory. Disadvantage of this is that it is a machine dependent language. Debugging is actually uh, difficult for the user. Debugging, that means if we need to correct the language, there may be some error, it will become extremely difficult for us to find in a row of zeros and ones one missing one, or any number we might have misplaced 0 to 1 or 1 to 0. So it will become actually very difficult for us to debug it. Its development is difficult. And it's not portable, or it's not, as well as it's actually machine dependent. So these are some of the advantages. We are talking about now how the microprocessor will communicate with the input, the output device, with the memory. It will be taking care of. There will be language, the machine language, the assembly language, and the low-level language or the high-level language. Machine language, these are simply binary digits that will be processed by the system. That's strings of zeros and ones. There are some advantages associated with this. There are some disadvantages associated with this. Next, you have the assembly language. These are some basic terminologies that will be taken care of today. The assembly language is the second generation language that was used for communication between the input devices, the microprocessors. It's actually made up of mnemonics. Made up of mnemonics. So what mnemonics represent simply, they represent symbols, oblique codes. So you can have alphanumeric digits that may be actually representing the language here. The mnemonics to machine language are actually first converted into the machine language, and for this we need now the translators. So the translators that will be required here is known as an assembler. A microprocessor can only understand one language, and that is the strings of zeros and ones. That's the binary language. Now, if the user is communicating through the input device using assembly language, that actually is made up of certain symbols or codes, we need to translate that for the microprocessor. So between the source and between the object, that is the microprocessor here, we have to make use of a translator that is known as an assembler. So the assembler this will come from the source, and this is going to the object. That's actually that may be a microprocessor here. So there's the assembly language programming done on this end. The translator, that's the assembler here, will translate this assembly language for the system into machine language. That's again binary digits, zeros and ones. So this is the second generation. The first and the second generation language, that's the machine language and the assembly language, together they are known as the low level language. Then came the high level language, what are also referred to as the third generation and the fourth generation language. So these are simpler for us as a user. They are simple English like statements, like you have done in case of MATLAB, using simple if and else logics. Program development is therefore easy. If A is equal to this, then B as then and B is equal to this, then the output will be A plus B, something like that. So these are simple English like statements. So this development of such a kind of language, program development, is easier for us as humans, and uh, debugging therefore is easier. But the translation will be required for the system. So you will, the microprocessor again will be able to only understand you are inputting something in the keyboard into the MATLAB, but for the microprocessor to understand it, for the processor to understand it, there has to be translation. This language has to be converted into binary numbers again, right? So you can use interpreters or compilers for such a kind of translation. Uh, you can, since there is translation required here, you can say that accessing the high level language is slower as compared to accessing the machine language for the system, right? but there are still advantages associated with this. It's still portable. It's portable. It is still less compact. It's not more compact. It is less compact. This is not an advantage. It will require more space, uh, but no need of architecture know-how. So we'll be taking up what is architecture in later classes. Uh, but for now, you can understand that the system's behavior, the system structure as a whole, what are the different components in the system in the microprocessor uh, talking about. We need not to understand its system architecture, its built up, its components. We need not need to have its information. We we simply can say, for example, you have done it in MATLAB or using C programming or R. These are high level language, simple English like statements. If this is equal to this and that, you do not need to know what is the microprocessor capability of performing the task or its architecture rather. So this language is easier for the user. It is not easy for, it is not something that is understandable by the microprocessor directly. So you will need to translate this language for the microprocessor using certain hardware or software devices like interpreters or compilers. Fine. We need to translate this language. So these are about the low level language and high level language that we can use for processing information, to feed the information to the microprocessor. The microprocessor in itself will only be using the strings of zeros and ones, that's the binary digits, for processing the data. So far we have understood what a microprocessor is, the language that will be required, the language that will be actually taking up with 8085. It is an assembly language, and we will see how we can also, we'll also be translating that language into machine level language for the system to understand it. Fine. Other terminologies that are associated with microprocessor. You have a bit. It's simply a binary digit, and it can either be 0 or it can be 1. Then you have a byte. So it's an 8-bit combination. Fine. You have a nibble. It's a combination. It's a combination of 4 bits. You have 1 kilobyte. Kilo here does not mean 1000 bytes. It means 1024 bytes. Or in other words, you can say 2 raised to power 10 bytes. You have 1 megabyte. It's actually 1024 kilobytes, or you can say 2 raised to power 20 bytes. 1 gigabyte is 2 raised to power 30 bytes. Fine. So these are actually the size of the memory that we are talking about. Simply talking about first the bit. Bit can simply be either it's 0 or it is 1. This is a simple binary digit number. Now a byte, a combination of 8 bits, a string of 8 bits, say for example 0000110100. If I can write this 0100000110, you can have any combination ranging from 00000000 to if you are talking about only alphanumeric digit, how about 0 and 7, it will run up to 11111111. Fine. So this will actually, this combination from zeros to one, eight, from eight zeros to eight ones. You can have a number of combinations, but all of those combinations will actually represent only one byte. Fine. Uh, if you are if we are only talking about 4-bit combinations, that is 0011 or 0000 to 1111, that will actually represent one nibble. Each of them will represent only one nibble. Next, with regards same the size, we have what is known as word or word length. Uh, so it's the number of bits that can be manipulated. Number of bits that can be manipulated by uh, that can be manipulated or processed, whatever you want to call, manipulated by the microprocessor, by the arithmetic logic unit of the microprocessor rather, at a time. It's known as the word or the word length of a microprocessor. Right? It's a group of bits that the microprocessor will be able to handle and process at the same time. Uh, Say for example, if we are talking about Intel 8085, it's called 8-bit microprocessor. Right? That means it can actually process 8 bits of information at the same time. Nowadays, if you are using i5, i7, we refer to these microprocessors as 64-bit microprocessors. Or even some of you might have 32-bit PCs, right? So that means actually it can process strings of 64 digits, 64 zeros and one combination at the same time. This much amount of data can be processed. This much word length can be processed at the same time. Now, with regards to the Intel 8085 that we'll be talking about in this course, it's a 8-bit microprocessor. That means it can handle 8 bits of data at the same time. This is something different from the address. We'll be also talking about address of such systems, and we'll handle that at a later stage. Right? So this is about the word length. So you need to understand bit, byte, kilobyte. Fine. Then you need to understand what is a word length. That means simply how much bit data your system can process at a time. That means simultaneously. In case of 8085, it's 8-bit. In case of your modern processors like i5, i7, they can handle 64 bits of data. These are actually commercially available in the if you look at in the R&D sectors, they have 128 bits, 256 bits already capable processors already functioning. Fine. Next terminology that we'll be dealing with is instruction. Instruction is simply a command that will be fed to the system or the processor. This instruction will be fed to the processor through accessing the memory and the input device, and this command will help us actually execute the information. What the task of this microprocessor is actually defined in the instructions. So some of these instructions may be designed with only one word, or maybe it may be a number of words that will be used to design an instruction for a microprocessor. We have talked about mnemonics already previously. It's simply a combination of alphanumeric digits or letters that will actually describe the instruction for the microprocessor. Program is a set of instructions now. One instructions is actually instruction actually refers to one particular task. But if the system is doing a sequence of events, a sequence of uh, tasks have been assigned to a system to perform in a special manner, in a specified manner, in a specified sequence rather, that will be accomplished by the system through a set of instructions, and that is referred to as a program. Fine. Instruction refers to only one particular task that is being fed to the microprocessor. Program refers to a set of that those tasks. If you have done already using MATLAB, C programming, you have written programs. So one of that, it consisted of instructions at different points. Fine. Then we'll be talking about actually opcodes. We'll be talking about opcodes a little bit later on. We have some other associated devices with the microprocessor, like a buffer. So what's a buffer here? It's a sort of a power amplifier that will not actually change the characteristics of the signal, but will make the signal stronger. Right? So a buffer is a power amplifier. It will not change the characteristics. Does not change the characteristics of signal. It will amplify the signal. What makes the signal stronger. Fine. In other words, we can say a buffer. If you have a system having an input 0, it will keep it 0, 1, 1. The power gain will actually represent a stronger signal, but it will not change its characteristics. It will not change the type of the signal. Fine. Inverter, on the other hand, inverts the logic. It will be like 0, 1 and 1, 0. You have tri-state buffers. These are some terms that we will come across at some point while studying microprocessors. So I am just trying to make you familiar with these terms. And it's a controlled buffer. Fine. So you can have the input, you can have the output, but you can control the state of this system by using an enabled device. So it's sort of a controlled buffer. So we have the microprocessor. We have talked about the language of the microprocessor. We are going through different terminologies associated with the microprocessors. Regarding the size, we have bit, byte, nibble, kilobyte, megabyte, the word length. You need to know what an instruction is. You need to know what a program is. You need to know what a buffer is, what an inverter is, what a tri-state buffer is. It's a control buffer. You can have active high tri-state buffers, active low tri-state buffers. You need to know about the different devices that I talked about earlier. Interpreter, compilers, assemblers. So interpreter, it may be a program that either executes the source code directly, or it will translate the source code into some efficient intermediate representation and immediately executes this. So that actually means interpreter. These are both interpreters as well as compilers used to transfer source code from a high level language into a lower level language. There are some differences in execution, so you need to know those. You will go through them on your own. Then you have some other tri-state devices that will come across. As I said to you earlier also, low tri-state buffers, active high tri-state buffers. Let me just give you the truth table of these. Active low tri-state buffer. So there is an enable switch now here. So there will be an input and there will be an output. So your enable can be 0 0 or it can be 1 1 for these combinations of inputs. Accordingly, you can have 0 or 1. Fine. So as I said to you, buffer does not change the type of signal. It will only amplify its signal response. As far as these two states are concerned, they are known as high impedance states, and you cannot, like you have seen also in flip-flops, at certain for certain devices, you may have a condition wherein your output may be undeterminable. Similarly, you have tri-state inverters. Active high tri-state inverters. Active high tri-state buffers. Active high tri-state. First talking about the buffers. Let me put it here. The active high tri-state buffers. So the difference between you can note the difference from the truth table. You have enable, you have input, and accordingly you have the output. For enable 1 1 0 0 0 1 0 1, you have the output 0 1, and this will refer to the impedance state, high impedance state. In case of a buffer, 0 signal remains 0 input, 1 remains output 1. Now if you are using a tri-state buffer, then you can control it using an enable device. In an active low tri-state buffer, for enable 0, the output will be you will get the output corresponding to input. For active high tri-state buffer, for enable 1, the output will respond to the input. Fine. Similarly, in the case of active low tri-state inverters, for active high tri-state inverters, you have enable, you have input, and you have output. Now for logic input, enable logic 1 and 1, the input 0 will give us an output of 1, the output input 1 will give us an output of 0. For enables 0, the inputs 0 or 1 will give us the high impedance state. Similarly, active low tri-state buffer, tri-state inverter, for an enable of 0 0 and 1 1, and corresponding inputs 0 1 0 1. The resultant output will be corresponding to low enable state, that is for a 0 input will have an output of 1, for a high input will have an output of 0, and this will be the high impedance state. Fine. Uh, so far, so we have talked about buffers and inverters. Buffers do not change the logic state of the input. The logic state will remain same. Now with the enabled capacity, by using a third uh, state, that is the enable state, we can control the output. Uh, we can control the output with respect to the input. Fine. Whether either it can be active high state inverter or it can be active low state inverter. Similarly, it can be an active high state buffer or an active low state buffer. In either of the cases, you can say for example active high state, the low state will actually result in high impedance corresponding to the input values. Next, we'll be talking about the bus. This is serial number 15. So what does a bus here mean? It's a means of transport that we actually know, even generally speaking, but we are talking about in terms of microprocessors here, or so we'll say a bus is actually a means of communication between one device and the another device. So for example, between the microprocessor and the memory, you will have a bus. Between the input and the microprocessor, you will have a bus. Between the output and a microprocessor, you will have the bus. So this is the input state. So this will be actually the bus. This is with respect to the memory. These are the buses. Fine, buses. And with respect to the output again, you have a bus here. So it simply transmits signal. So these are simple hardwired lines of communication through which the microprocessor communicates with the peripherals, or vice versa. The peripherals can communicate with respect to the microprocessor through these devices. Now there will be modes of transmission associated with this. One will be serial mode of transmission, another one will be parallel mode of transmission. In serial mode of transmission, one by one transmission of bits takes place. So one bit at a time transmits. While as in case of a parallel mode of transmission, all bits are forwarded at the same time. Fine. Also, so you can communicate between the input and the output, between the output and the you can communicate between the input and the microprocessor, between the microprocessor and the output, between the microprocessor and the memory using a bus. Now, this communication can be either a series transmission or a parallel transmission. That means either one by one or one bit at a time will be forwarded, or all the bits will be forwarded together, and as well as then there will be types of buses depending upon whether this bus is between the input and the microprocessor or between the microprocessor and the memory, whatever. So you will have a data bus, you will have an address bus, and you will have control bus. So as far as the data bus is concerned, it will carry the data from the input or the memory to the microprocessor. Fine. To the processing unit actually. So that is the data bus. Address bus will actually will be actually taking care of the address is issued to, basically the address is actually issued to the microprocessor, and on the lines on this address is actually transmitted uh, from the memory to the microprocessor and is known as the address bus. Fine. The microprocessor can actually identify various peripherals through this address. ठीक है, so it's simple like the language goes, किसी का address पता होना. So microprocessor will be able to identify these peripherals by knowing the address of this peripheral. ठीक है, अब वो input device हो, output device हो, memory हो, so, or other devices that will be actually connected to this microprocessor, other device output and input devices that will be connected to this microprocessor can be identified through their addresses, and this address will actually here be strings of zeros and ones. That's actually a binary number. Fine. So this address is carried along, is also issued to the microprocessor, and this is carried to the microprocessor through the line known as address bus. The line, the data, the communication line that will actually carry, that will carry this address to the microprocessor is known as the address bus. These are two important buses. The data bus actually carries the data that needs to be processed. The address bus will not be, it will, both will be carrying zeros and ones only. But the data bus will be carrying the data that is actually to be executed, while the address bus will be actually carrying the location or the address of the memory from which that data needs to be collected, say for example. So one, you need to identify the location of the device, then only you can carry forward that. Once you have the location of some particular device, then only you can ask that device to send that address, send the data to you. So one, it will carry address of certain locations, and then it will carry data from that location. That address that is carried forward to this location is done to the address bus. Data that will be carried forward to this location is known as the data bus. This data bus is actually a bidirectional bus. This is important here. Data bus is bidirectional. The address bus is unidirectional. Unit bidirectional means that data will have to be, microprocessor will carry, will write or read, will read the data from some location as well as write the data to some location. Fine. But as far as address goes, so this data bus has to be bidirectional. That means it will have to carry, it will have to transmit signal to the microprocessor as well as take the signal from the microprocessor. While as far as the address bus goes, this is a unidirectional bus because the microprocessor only needs to access the location of the, that needs to know the address of a device to which it has to read or to which it has to write. This will come from the peripheral only. The microprocessor needs not to send any address to any peripheral. Fine. And control bus, it will actually carry the control signal. So there are other things that need to be monitored in a PC, such as the timing, the coordination, the synchronization. So all these controls elements that are associated with the microprocessor, uh, coordination, timing, synchronization, needs to be also carried forward through certain lines, and these there are separate lines for them. These are known as the control lines, and they will carry this type of information. There may be related information or unrelated information that will be seen. uh, Now, as far as the 8085 goes, since we are processing 8 bits of data at the same time, so data bus will actually be having a, it will be executing 8-bit instructions at a time. As far as the address bus goes, as far as the address of the peripherals go, uh, address bus is 16-bit. The memory that will be the addresses of these peripherals will be 16-bit digits rather than being 8-bit digits. So this thing needs to be distinguished in an 8085. The data processed by the 8085 is only 8-bit, so it's only an 8-bit microprocessor. We will not call it a 16-bit microprocessor. Although the address location, the memory locations, they are 16-bit. The word length of address bus is 16-bit. The word location of the addresses are the 16 bits, but since the data is not processed, 16-bit data is not processed by the microprocessor, we will not call it a 16-bit uh, device, 16-bit device. Fine. Uh, so we'll leave it at this point today. Today we have discussed about the microprocessors, the basic introduction, what are microprocessors, how they are different from microcontrollers. Uh, we have discussed about the language that the microprocessor understands. We have discussed about the structure. We have discussed about various terminologies that will be associated with the microprocessor, starting with general simple size related terminologies, bit, byte, extra, buffers, inverters, tri-state buffers, tri-state inverters. We have talked about different types of buses in the microprocessor, associated with the microprocessor: data bus, address bus, control bus. Uh, we will relate all these things to 8085 later on. So that's all for today.